All right. Hey guys, Mr. Kyle, Myers Mathematics, and we're going to jump into it. This is the last question in this particular worksheet, Systems of Equations Word Problems, that we're going to do. It's number 11. Kind of a weird number to end on, but it is what it is. Let's just jump into this boat. It's traveling 336 miles downstream and back. I like to kind of draw the picture as we go. Kind of helps me to visualize what is going on. So I'm going to draw a boat, and viewer beware here. I'm really bad at drawing, so you can let me know how bad I am in the comments here. There's my boat. Okay, so it's going to travel 336 miles downstream. Whoop, whoop, whoop. So the stream's going this way. Downstream. And you have the bank over here. And another bank over here. So here's the stream. And 336 miles. So let's just say that that distance is like this. 336. Right? So I'm kind of like taking notes as we go. I'm taking picture notes. So boat travels 336 miles downstream and then back. The trip downstream, so this way, takes 12 hours. The trip back takes 14 hours. Not that much longer, so the stream must not be that strong. Right? Doesn't take that much longer. 12, 14, pretty close. What is the speed of the boat in still water, and what is the speed of the current? Okay. So anytime you're dealing with boat or boat and stream, or let's say plane and wind, those are the top two by far. There's other ones, I'm sure, but things where you have some sort of vehicle of some kind, and then you have some sort of nature affecting how that vehicle is going, the rate. So rate is what we're talking about here: distance, rate, time. So we have distance, we have rate. If you divide distance into time, you get rate. So distance is equal to rate times time is the formula I normally remember. So I would say distance equals rate times time. And let's say that the downstream is blue, maybe. It's the blue equation. Okay. So distance, well, the distance is the same every time. It's 336. Okay. The rate is made up of two components. We've got the boat, which is, traveling. It's got an engine. So it's traveling and it's got an engine, or the sail. I drew a little sailboat. So it's got something going on. And will probably make more sense to say it has an engine, because wind might affect it differently coming back the other way. But anyways, we'll say it has an engine. So the boat engine is making it go a certain speed. And if it's going downstream, that means it's going along with the stream. It's going to take less time. It's 12 hours versus 14 hours. It takes less time because it's going faster. So we're adding the current, and that's our rate. The time is 12. Okay, so we finished setting that one up. So distance equals rate times time, or the DIRT formula, as I like to say. If you kind of make the equal sign a little bit shorter, it kind of sort of looks like it could pass for an I, lowercase I. If you use your imagination. So it's the DIRT formula, D-I-R-T. Distance equals rate times time. Distance, rate, time. Distance and time, we're just plugging in numbers. Rate was a little bit complicated, but these problems always work out the same way. So if you get used to how this particular problem works, all the other problems that are like this, vehicle and nature type problems, they all work out that same way, where we have the vehicle plus the nature. If you're traveling with the nature, if you're going against the nature, it's the vehicle minus the nature, which brings me to our next equation. We've got distance equals rate times time. Distance is still 336. The rate, we don't know, but we know it's going to be the vehicle minus the nature, and then the time. The time is 14 hours. Okie dokie. I think we should be able to divide each of these by 12 and 14 on both sides respectively here and get nicer equations. I believe so. Because remember, that is the goal, is to try to make our equations as nice as possible. 12 would go into 33 two times without going over. So it'd be 24 from 36 would be a 9, 96. 12 times 8 would be 96. So that's 28 times. B plus C. Okay. On the other one, I really don't know if that number divides by 14, but I'm just going to kind of take a leap in faith and say that it does. And we'll find out here in a second. So 14 would go in twice without going over. That'd be 28. So I'd have 5 left over, and then 56 times 4? 14 times 4? 4 times 4 would be 16. Carry 1, 4, 5, 56. Yeah. So 24. Okay, so it worked. B minus C. Okay. So I think elimination method is probably the way to go here. I'm going to move this up a little bit. So otherwise I'm going to run into my face here. So now elimination method. Ha ha ha. Finally. Prefer elimination method usually, if I can help it. So we line them up, and I didn't have to multiply either equation by anything because the C's were already opposites. So we're already good to go there. So I don't need to do anything with that. I just add them up. And the reason why this method even works, by the way, is because I'm actually adding 24 to both sides. You can add anything you want to both sides of the equation because it's an equation, right? I can times by 2 on both sides. I can divide by 12 on both sides. I can add 24 to both sides. I am actually adding 24 to both sides of the blue equation. It's just that on one side, instead of adding 24, I'm adding what it's equivalent to. We know that b minus c equals 24. So essentially, I'm adding 24 to both sides. And that's why elimination method works. You're just adding a number to both sides. So 28 and 24, that's going to be 52. C minus C cancels. B plus B is 2B. 2B or not 2B? And then I take a half, which would be 26. Okay, so I'm going to say this again because it's a new video, but normally I like to circle my answers, not box them, because I want to double check before I box those answers. So now I'm going to plug in 26 into here. 24. And you could solve it the traditional way, but just looking at this, I'm like 26 minus something is 24. Okay, well then C has to be 2, right? 26 minus 2 would equal 24. So C is equal to 2. Now you can solve it traditionally. If you did, you'd have to subtract 26 on both sides, and then negative 2 would equal negative C, and then you'd get rid of the negatives, and you could do it that way, but I figure it's just kind of faster to do it that way. Okie dokie. Oh, and I forgot to label this one. This one's my yellow one right here. And that's 14 in yellow. Okay, so that's my yellow equation. So I just finished plugging into the yellow equation. I'm going to use the blue equation to check to make sure everything is up to snuff here. And I'll probably just start with the version where I already divided both sides by 12. I think that's probably fine. So B is 26. I'm going to go ahead and put a plus right there. B is 26, and C is 2. Yeah, that works. That adds to 28. So we are good to go. That is the answer. And now that we know that's the answer, we can box those guys. And let's see if I can, how far can I move this down? Not that far, actually, until I run into my face. So move it over here a little bit. There we go. So there we go. Those are our answers. The boat is traveling 26, what are the units? Miles per hour. And the current is only 2 miles per hour. Very slow current. So that's the answer. Lock it in. There we go. And of course, if you find this helpful, you can go see other videos that are on the channel. like and subscribe, turn on the bell for notifications. And I have a guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. Link is in the description below at my website, myersmathematics.com. And also, if you are looking for tutoring, you can shoot me an email. I believe I have my email in the description below as well. So shoot me an email if you're interested in doing math tutoring. I tutor everything from Algebra 1 to Calculus 3. All right, have a blessed one, y'all.